Welcome to the Wolfram Language in Section 21 of Fast Introduction for Programmers. This section is about getting and using information about the real world. It is usually convenient to specify real-world entities using natural language. For example, typing Control equal gives a box for entering natural language input. This input specifies an entity for the city of Los Angeles. In the Wolfram language, real-world entities are just another kind of symbolic expression. You can use input form to see the structure of that expression. The percent sign here refers to the previous output, and Los Angeles is represented by an expression with a head of entity. Entities like Los Angeles have many properties, and many of those properties have values. For example, this uses the entity value function to give the value of the population property for Los Angeles. You can get a list of all of the properties for an entity by entering the entity followed by the word properties in square brackets. For example, this gives the available properties for Los Angeles. Natural language is convenient, but it is frequently ambiguous, since the same natural language input can refer to many different entities. The natural language system in the Wolfram language includes tools for resolving those ambiguities. For example, after entering the natural language input for Los Angeles, the three dots in the display identify a button that you can click to bring up a dialog box for selecting between different interpretations of that input. Here, the dialog box shows the name Los Angeles can refer to any of several different cities or to various other entities, and the dialog box also provides for making a selection from among those interpretations. For example, selecting Los Angeles, Philippines chooses that city as the interpretation of the original input. Some natural language inputs refer to multiple entities. For example, there are several German-speaking countries in the world, so this input refers to a list of entities rather than to a single entity. The array of dots in that display indicates that the result is an entity list rather than a single entity. You can use the entity list function to see the individual entities in that list. Many functions access real-world entities and properties automatically as needed. For example, this input uses the geoposition function to get the geographic coordinates of the Eiffel Tower. Those coordinates are based on the coordinates property of the Eiffel Tower entity. This next example shows the geolistplot function, which automatically looks up the real-world entities and the real-world properties necessary to draw an image. Many real-world properties have units. You can use natural language input, as in this example, to enter quantities with units. The result is a symbolic expression with a head of quantity. You can also enter that quantity directly, like this, without using the natural language system. Some real-world information involves times and dates rather than properties of entities. For example, this gives the time of sunset tomorrow. The result is returned as a symbolic date object expression. That's the end of the examples for this section. One good source of information about real-world data in the Wolfram language is the Wolfram Alpha website, www.wolframalpha.com. Wolfram Alpha is the system that powers most of the examples in this section. You can also get information by selecting Wolfram Documentation under the Help menu to bring up the Documentation Center page and clicking any of the buttons for areas of interest. For example, clicking Geographic Data and Computation and choosing Geographic Data and Entities brings up a page with links to all of the geocomputation functions that were used in this section.